Hello, my dear student. In previous video, we have discussed the carrier transport phenomena, and that carrier transport phenomena is mainly depend on two factors. One is the mobility and second is the resistivity. In previous video, we have discussed the first factor is mobility, and in this video, we have discussed the resistivity. The resistivity is defined as the proportionality constant between the electric field and the current density. Resistivity the resistivity rho is defined as the proportionality constant. Resistivity rho is defined as the proportionality constant between the electric field and the current density J. Resistivity rho is defined as the proportionality constant between electric field and current density J. That means that sigma, and we know relation that sigma is equal to rho into J, and that rho is the resistivity, J is the current density, and this is the proportionality constant, that is this is the epsilon. That epsilon is equal to rho into J, and that rho is the resistivity and J is the current density, and that is the epsilon, not sigma. Okay, then the reciprocal of this resistivity is conductivity, and its reciprocal value कशाची resistivity its reciprocal value is the conductivity, that is हा काय sigma, हा epsilon. Sigma is equal to 1 upon rho. आता J काय आपला, J epsilon is equal to rho into J. That means here according to that equation आपल्याला J काय भेटेल, J is equal to ह्या इक्वेशन J is equal to epsilon आणि हा rho काय होणार इकडे येणार. Okay, reciprocal value reciprocal value is the conductivity, and conductivity is denoted by sigma, and sigma is equal to 1 upon rho. But आपण इकडे example घेतला, epsilon is equal to rho into J. मग J ची व्हॅल्यू काय येणार, हा rho इकडे याला काय होणार मल्टिप्लाय. ओके, and but 1 upon rho is equal to sigma, and that means J is equal to that sigma into epsilon. J is equal to sigma into epsilon. But for semiconductor with both electron and holes, but for J is equal to sigma epsilon, that is the epsilon, and it is the proportionality constant of electric field. Simply इथे आपण E चा सुद्धा यूज करतो, J is equal to sigma into E. But for semiconductor with both electron and holes, for semiconductor with both electron and holes as carriers, then we obtain that rho is equal to 1 divided by sigma. This, according to that equation, sigma is equal to 1 upon rho, and that rho is equal to 1 upon sigma, and therefore 1 divided by q mu n into n plus mu p into p. This equation काय होतं, reciprocal value is the conductivity, and conductivity is equal to sigma is equal to 1 divided by rho, according to that equation. But for semiconductor with both electron and holes as a carrier, then we obtain that rho is equal to 1 divided by sigma, and this is equal to 1 upon q into mu n into n plus mu p into p. Mu p into p. This is कशासाठी? For semiconductor with both electron and holes. That rho is the resistivity is equal to 1 upon sigma is equal to 1 divided by q mu n into plus mu p p. This is the expression. This is the expression for resistivity. This is the expression for resistivity of intrinsic semiconductor. This is the expression for the resistivity of intrinsic semiconductor. We know intrinsic semiconductor and extrinsic semiconductor. Okay. In previous video, firstly introductory lecture मध्ये आपण घेतले what is mean by intrinsic semiconductor and what is mean by extrinsic semiconductor. But that equation rho is equal to 1 upon sigma is equal to 1 divided by q mu n plus mu p p, and this is the expression for resistivity of intrinsic semiconductor. Then for n type semiconductor, for n type semiconductor, for n type semiconductor we have n is greater than p. For n type semiconductor we have n is greater than p. That means that rho is equal to 1 divided by sigma is equal to 1 divided by n is greater than t. That means that mu p into p will be cancel out and remaining term 1 divided by q in bracket mu n into n, mu suffix n into n. For n type semiconductor we have n is greater than p, then rho resistivity is equal to 1 upon sigma is remaining as that equation 1 divided by 1 divided by q mu n into p. Okay. And then for p type semiconductor, for p type semiconductor we have काय असणार आहे? P is greater than n, and therefore equation is resistivity rho is equal to 1 divided by sigma is equal to 1 divided by sigma is equal to 1 divided by q mu p into p. For p type, this is the expression for resistivity of p type semiconductor, and for p type semiconductor we have p is greater than n. That means that rho is equal to 1 divided by sigma is equal to 1 divided by q into mu p into p, and this expression is known as a resistivity. This expression is known as a resistivity of the p type semiconductor. And we know p type semiconductor and n type semiconductor, okay. We early in previous video we have discussed the p type semiconductor and n type semiconductor. Okay. And intrinsic semiconductor, that means आपण काय करतो इंट्रिन्सिक सेमीकंडक्टर मध्ये की इम्प्युरिटी ऍड करतो. इम्प्युरिटी ऍड करतो. इम्प्युरिटी ऍड कशामध्ये करतो? प्युअर सेमीकंडक्टर मध्ये. आणि आपला जो इंट्रिन्सिक सेमीकंडक्टर आहे तो जो फॉर intrinsic semiconductor which are the pure semiconductor, but in extrinsic semiconductor मध्ये काय करतो आपण? When impurity is added to the pure semiconductor, and that method is known as a doping. And according to that आपण एक्सट्रिन्सिक सेमीकंडक्टरचे दोन टाइप बघतो. एक आहे पी टाइप सेमीकंडक्टर आणि एक आहे एन टाइप सेमीकंडक्टर. आणि मग त्यामध्ये काय करतो की पेंटाव्हॅलेंट इम्प्युरिटी आणि ट्रायव्हॅलेंट इम्प्युरिटी काय करतो आपण ऍड करतो. ट्रायव्हॅलेंट आणि पेंटाव्हॅलेंट इम्प्युरिटी काय करतो ऍड करतोय. ओके. मग तो अप्लाय काय एन टाइप सेमीकंडक्टर अँड पी टाइप सेमीकंडक्टर. ओके. And this is the two types, and this is the resistivity. मेनली करिअर ट्रान्सपोर्ट फेनॉमेनॉवरती दोन फॅक्टर डिपेंड होते. कोणते? एक होता मोबिलिटी आणि एक होता रेझिस्टिव्हिटी. मोबिलिटी प्रिव्हियस व्हिडिओमध्ये बघितला आपण. आता काय बघितलं आपण? रेझिस्टिव्हिटी. रेझिस्टिव्हिटी इज डिफाईन ॲज द प्रपोर्शनॅलिटी कॉन्स्टंट बिटवीन इलेक्ट्रिक फील्ड दॅट इज एप्सिलॉन अँड द करंट डेन्सिटी J. वी नो द J इज इक्वल टू सिग्मा इंटू रिलेशन नो नाही, पण आता इथे आपण इक्वेशन काय बघितलं की J इज इक्वल टू सिग्मा इंटू दॅट एप्सिलॉन. एप्सिलॉन तो प्रपोर्शनॅलिटी कॉन्स्टंट घेतला, ई नाही घेतला इथे काय घेतला की प्रपोर्शनॅलिटी कॉन्स्टंट. ओके. नाही, इन द नेक्स्ट व्हिडिओ वी हॅव डिस्कस द हॉल इफेक्ट. आता हॉल इफेक्ट काय की हॉल इफेक्टला काय करतोय की हॉल इफेक्ट म्हणजे मीन्स की हॉल इफेक्टला काय करतो की कंडक्टर काय करतोय की कंडक्टरला आपण काय करतो मॅग्नेटिक फील्ड देतो. कंडक्टर कशामध्ये ठेवतो किंवा मॅग्नेटिक फील्ड देतो. आणि मग मॅग्नेटिक फील्ड दिल्यानंतर वी नो दॅट मॅग्नेटिक फील्डची डायरेक्शन कशी आहे? नॉर्थ पोल टू साऊथ पोल. आणि आपण काय करणार आहे की त्या कंडक्टरला बॅटरी कनेक्ट करणार आहे. बॅटरीची डायरेक्शन कशी आहे? पॉझिटिव्ह टू निगेटिव्ह. आणि मग तिथे जो पोटेन्शियल डिफरन्स भेटणार आहे तो आपल्याला मेजर करायचा अकॉर्डिंग टू हॉल इफेक्ट. In previous video we have discussed the Hall effect.